Okay, so the midpoint formula tells us we're going to take the average of the x-coordinates. So that's x1 plus x2 divided by 2. Then you take the average of the y-coordinates, y1 plus y2 divided by 2. And that will give us the coordinates of the midpoint. So let's go to where it says distance formula. The distance formula is going to be the square root, in parentheses, we're going to have x2 minus x1 squared, close your parentheses and square it, plus the quantity of y2 minus y1 squared, all under the square root sign. Those are going to be the two formulas you need to memorize for your test, which will be next week. So we got the midpoint formula, we got the distance formula, and I will teach you how to use those two formulas. Graphing. All right, we're going to skip all the calculator parts. Let's go to where it says guided practice. So we're going to scroll down to where it says guided practice. You know what we need to do? We need to do other practice before we do that. Okay, I'm going to change one of these problems. For number 4, it says find the midpoint using the midpoint formula. Let's say I told you point A is the point, I don't know, 4, 5. And point B is the point -10, 3. All right, so I'm going to ask us to find the midpoint of segment AB. How are we going to find the midpoint? We're going to use the midpoint formula. So the midpoint is going to be x1 plus x2 divided by 2, y1 plus y2 divided by 2. I'm going to go ahead, I'm going to call A x1, y1. I'm going to call B x2, y2. All right, now we're going to plug into the midpoint formula. So it's saying take my x's and add them together. So that's going to be 4 plus a -10, and then we divide that by 2. Then it says take your y's and add them together. So this is going to be 5 plus 3 divided by 2. Yes. You're okay? Okay, so now what is the midpoint going to be? Let's simplify this. 4 plus a -10, isn't that -6? And we'll divide that by 2. 5 plus 3 is 8. We'll divide that by 2. So what are the coordinates of the midpoint? The midpoint is going to be -3, 4. That is the midpoint of the segment that has AB. So midpoint is a physical point. What does the midpoint do to the segment? What does the midpoint do to the segment? Nora? Good. It's split it into 2 equal parts, right? So if -3, 4 is the midpoint, to the left of -3, 4 is the same distance as to the right of -3, 4. Can I erase this to do the next part? All right, so now I want to take that same point, I want to take the same coordinates A, which is 4, 5, and B, which is negative 10, 3. And now this time I want to find the distance between the 2 points. When I find the distance between the 2 points, is it going to be a point or is it going to be a length? It's going to be a length, so we're not writing it as a coordinate, right? It's just going to be how long it is. So we're going to use the distance formula. To use the distance formula, we're going to say the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, once again, I'm going to call A x1, y1. I'm going to call B x2, y2. So we're going to have we're going to have negative 10. We're plugging in negative 10 minus 4 squared plus 3 minus 5 squared. Right, when using the distance formula, you need to simplify completely underneath the radical. So negative 10 minus 4, isn't that a negative 14? So we're going to have a negative 14 squared plus 3 minus 5 is a negative 2, and then we're going to square that. You have to keep simplifying underneath the radical. So D will equal, the distance between the 2 points is going to be negative 14 squared, which is 196 plus 4. What's 196 plus 4? 200. Now, this is the square root of 200. Technically, we can simplify this. I know you learned it already, but I'm going to reteach you how to simplify radicals, but not till chapter 9. So the purpose of these units, if it's a perfect square, when I say a perfect square, like the square root of 25, I expect you to simplify it. What's the square root of 25? 5. So if it's a perfect square, I expect you to simplify it. If it's not a perfect square, like 200, you could just leave it in the radical. So if it's a perfect square, I expect you to simplify it. If it's not a perfect square, you can leave it in the radical. So the distance from A to B is root 200 units long. All right, let's do more practice. Can I erase this? Anybody copying? All right, so here I'm going to switch things up a little bit. So it's saying M is the point 1, 8, is the point between A, which is negative 5, 5, and another point B. Find the coordinates of B. So I'm now giving you the midpoint. I'm giving you one point, and I want you to find the other endpoint. Because they discussed midpoint in the problem, I'm going to write out the midpoint formula. And what is the midpoint formula? It is the midpoint equals x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. But now it's saying M is the midpoint. So these coordinates, 1, 8, doesn't that go in for where it says midpoint? So that 1, 8 goes in where it says midpoint. So that means 1, 8 is equal to, now we have A, which I'll call x1, y1. Do we have point B? No, I'm going to call point B x2, y2. So if we're plugging into the formula, we're going to have negative 5 plus x2 over 2. And then we're going to have 5 plus y2 over 2. I'm going to stop here right now. I need to make sure everybody understands why I put all these numbers where I did. Does anybody not understand why I put every number that I put down? We're all okay? Okay, so now what do we do next? Well, do you agree this is your x coordinate and this is your y coordinate? So when we simplify this side right here, -5 plus x2 divided by 2, doesn't that have to equal 1? So we're sort of splitting up this equation now. So we're going to say -5 plus x2 divided by 2 has to equal 1. When I take the average of the x coordinates, it has to come out to 1 because that's the coordinate for the midpoint. So now we simplify this. We know how to solve this equation from Algebra 1. Don't I start off by multiplying by 2 on both sides? So now we're going to have -5 plus x2 equals 2. What should I do now? Add 5. So now we get x2 is equal to 7. Did we find the x coordinate of that point? Yeah, what do I have to do now? Find the y coordinate. So now I know 5 plus y2 divided by 2, doesn't that have to equal 8? So now that's going to be the next equation I write. 5 plus y2 over 2 has to equal 8. And we're going to go ahead and solve this just like we did before. So I'm going to multiply by 2 on both sides. And I have 5 plus y2 equals 16. So y2 will equal 11. Find the coordinates of B. Did we find the coordinates of B? Yes. So I'm going to say B is equal to 7, 11. Are we ready for the next one? Okay, so now it's saying find the distance between point P, which is 3K, 4K, and Q, which is 2K, K. All right, so I'm going to go, it says find the distance, so which formula should I use? The distance formula. D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. I'm going to call P x1, y1, and I'll call Q x2, y2. So now we're going to plug in. I'm going to have 2k minus 3k squared plus k minus 4k squared. And now we just simplified. Don't be scared by the variables. 2k minus 3k, isn't that negative 1k? And then k minus 4k, isn't that negative 3k? We keep simplifying. We keep simplifying. What's negative 1k squared? Isn't that just k squared? What's negative 3k squared? 9k squared, right? 9k squared. What's 1k squared plus 9k squared? 10k squared. I'll let you leave it like that for now. So don't get scared by the formulas. Don't get scared by the variables. You go about it the same exact way. Ethan, was your hand up?
Yeah. Why is it still squared even after? Like, why is it still labeled as 1k squared and 9k squared after squaring it out?
So like, so we did the negative 1k and raised it to the second power, so that was k squared, right? And then we did the negative 3k and squared it, that was 9k squared. But because there's a plus sign between them, you can't just like cancel out the radical. You can't just take the square root of 1k and take the square root of 9k. Because there's a plus sign between them, you have to simplify what's underneath the radical. Okay, so this is bringing some geometry into things now. Given D is the midpoint of AB, show algebraically why triangle ADC is congruent to triangle BDC by side, side, side. All right, so if we're showing this algebraically, we want to prove, let me highlight, triangle ADC, that's this triangle right here, is congruent to triangle BDC, which is this triangle right here. And we want to show them congruent by side, side, side. Well, let's start off with this side from A to O. Can we just count the units for A to O? Because it's a vertical line, we can just count. How many units? Oh, that's C, not O. How many units from C to A? 0 all the way up to 6, right? Doesn't that mean that's 6 units long? So this segment is 6 units long. All right, what about from C to B? How many units long is that? AJ? Another 6 units long. Well, can't we say CD is reflexive? So we got a side, we got another side, and CD is reflexive. Now, I'm allowed, since everything's drawn to scale, since this is a graph, I'm allowed to count on the on vertical line segments. I'm allowed to count for horizontal segments, but can I count for slanted segments? You can't count for slanted segments. That doesn't work. All right, so now how are we going to do this? Given D is the midpoint of AB, show algebraically why triangle ADC is congruent to triangle BDC. So what I need to do is sort of a two-step part right now. I first need to find the coordinates for D. I need to find the coordinates for D. And if D is the midpoint of AB, can I find the coordinates using the midpoint formula? Absolutely. Point A is the point 0.06. And isn't point B the point 0.60? If I lose you, please stop me. So now I'm going to find the coordinates for D. D is going to equal x1 plus x2 divided by 2, y1 plus y2 divided by 2. So point D will be 0 plus 6 divided by 2, and then 6 plus 0 divided by 2. 3, 3. Okay, remember they want us to prove this algebraically, that these two triangles are congruent by side, side, side. Well, we got side, we got the side 6s, we got the reflexive side. How am I going to show that these two sides are the same length algebraically? So A to D and D to B. How would I show that they're the same length algebraically? Any ideas?
I guess because you found the midpoint and like they're congruent, I guess.
Well, that's how we would do it in a proof, but they're saying show it algebraically, so I actually have to show that this length and this length are the same with numbers. How would I do that? Amanda? We can use the distance formula. So let's go and use the distance formula now. So I'm going to find AD. The length of AD is going to equal the root of x2 minus x1 squared plus y2 minus y1 squared. So now I'm going to have 3 minus 0 squared plus 3 minus 6 squared. So we're going to have 9 plus 9. Is everybody okay with how I got 9 plus 9? I skipped squaring. I subtracting then squaring. We're okay? Me skipping a couple steps. So then isn't AD, the length of AD, the root of 18? So that means this is root 18, the length of it. What else do I have to find now? Ethan?
AB.
AB?
DB.
DB, you got it. So now we want to find DB. So DB is going to equal, again, the distance formula, x2 minus x1 squared plus y2 minus y1 squared. We're going to plug in, and we're going to have 6 minus 3 squared plus 0 minus 3 squared. That's going to equal the square root of 9 plus 9. Isn't the square root of 9 plus 9, again, the root of 18? So did we show these triangles are congruent algebraically by side, side, side? Yes. All right, can we do another one? Anybody still copying this? Okay. So again, this is the last problem we're doing today. Show algebraically why triangle ABE is congruent to triangle DCE by side, angle, side. Well, right off the bat, which angles are we talking about for side, angle, side? What are the angles we know? Ethan?
ABE and DCE.
You got it. I'm going to call them 1 and 2. Aren't these two angles congruent because of vertical angles? All right. So now we need side, angle, side. I'm going to go ahead right here, and I'm going to say that from point E to B, right here. Is that a horizontal line? Yeah, so can we just count the units? Absolutely. So let's count the units. 1, 2, oh wait, are these going by? Where is this starting? I'm trying to look at my numbers here. This is 0 all the way to, what is that, 5? All right, so this is 5 units long. And then we're going from 5 all the way to 10, which is another 5 units long. So did we show that these two segments are congruent? Yeah, because they're both 5 units long. Now to do side, angle, side, what's the next segments we have to show are the same length? Which segments do I need now? Symmetry. AE, and what was the other one? ED. The problem is because these lines are slanted, can I just count? No, you could only count horizontal and vertical segments. You can't count diagonal segments. So what am I going to have to do to find the length of A to E and E to D? Use what? The distance formula. You got it. So I'm going to use the distance formula for AE. let's see, do we agree A is 0, 0? And E is the point 5, 4? And D is the point, what's D? 10, 8? Do you guys all agree with my points? Yeah? Okay, good. So AE is going to be the square root of x2 minus x1 squared plus y2 minus y1 squared. All right, so I'm going to have 5 minus 0 squared plus 4 minus 0 squared. That's going to be 25 plus 16. And that's going to be the square root of 41. So now that I found the length of AE, what am I going to find the length of this time? DE, exactly. So let's find DE. So again, it's x2 minus x1 squared plus y2 minus y1 squared. We are 10 minus 5 squared plus 8 minus 4 squared. So that's going to be 25 plus 16. So once again, it is the square root of 41. Did we show these two triangles congruent by side angle side? Absolutely. All right, we are done for today.